Guten Morgen. So today let us continue with another method called elimination method to solve a pair of linear equation. In this method, as the name suggests, we will be eliminating one of the variable and solving for other. Let us start with an example. So the example says the ratio of incomes of two persons is 9:7 and the ratio of their expenditure is 4:3. If each of them manages to save 2000 per month, find their monthly incomes. So we have information here about the income ratios and the expenditure ratios and how much they save. And we need to find the monthly incomes. Okay, so let's say their income uh, let's denote income with variable x and expenditure with variable y. So now for the first person, the income, let's say it is 9x. We'll write both the, so if for the first person the income is 9x, for the other person the income should be 7x, because the ratio should be 9:7. Now the expenditure is y. So for the first person the income is 9x, the expenditure will be 4y. 9x minus 4y. Now for the second person, since the expenditure has to be in the ratio 4:3, the expenditure will be 3y. And this is savings minus expenditure will be the, sorry, income minus expenditure will be the savings for first person, which should be equal to 2000, and again income minus expenditure should be 2000 for the other person. So these are our two linear equations. Now what do? We want to eliminate one of the variables, either x or y. So in this case, it's more easier to eliminate y. So what we do is multiply both of these equations with some non-zero constants so that they will have the same coefficients. So here the coefficient of y is 4, here is 3. So let us multiply this equation with 3 and this equation let us multiply with 4. So we are just multiplying with these coefficients. So if we multiply this with 3, this gets 12. If you multiply this with 4, it becomes 12 as well. And then we can eliminate them. And as we know from our last discussions that if we just multiply a linear equation with a non-zero constant, then it just scales up the line and it will remain the same line. So it doesn't affect the line that we are solving for. Okay. So from this, if we do perform this operation, what do we get? The first equation that we get is 27x minus 12y is equal to 6000, and the second equation becomes 28x minus 12y is equal to 8000. Now we simply subtract this equation from this. So when we subtract this, the sign changes. So it becomes from plus to minus, this one goes from minus to plus, and this one becomes plus to minus. And what we get if we do this, 27 minus 28 minus x, this gets cancelled out, so it becomes 0, and this is equal to 6000 minus 8000 minus 2000, and we get our solution. X is equal to 2000. Now we simply substitute x in equation 1. We get 9 multiplied by 2000 minus 4y is equal to 2000. Therefore we get minus 4y, 2000 minus 18,000 minus 16,000. Therefore y is equal to 4000. So we get our solution for X and Y. I mean, the question they said monthly income. So for the monthly incomes for first person, the monthly income would be 9x, that is equal to 18,000. And for second person, the monthly income would be 7x, equal to 14,000. Now we can quickly check if it matches or not. So the monthly income for first person 18,000, the expenditure would be 4 times 4, 16,000. So 18,000 minus 16,000, 2,000 savings for first person. For second person, income 7x, 14,000, expenditure 3y, 12,000, 14,000 minus 12,000, 2,000. So it satisfies the equation, it satisfies the information given. So yeah, this was an example for solving. Just a quick review what we did. We just made the coefficients for one of the variable equal by multiplying with a non-zero constant, and then we just eliminated it, we subtracted it, and we solved for the variables. Okay, let us have a look at another example. So we have two linear equations. 2x plus 3y is equal to 8, 4x plus 6y is equal to 7. So let's say we just want to make these coefficients equal. What do? We multiply this equation with 2 and this equation with just 1. So we multiply this equation with 2, this equation we multiply with just 1. So what do we get from this? We get 4x plus 6y is equal to 16, and from the other equation we get 4x plus 6y is equal to 7. Now let's say we subtract these equations. What do we get? This cancels out, this cancels out. So we get 0 is equal to 9. Okay, 0 is equal to 9. Is it? No. So we get an incorrect statement. Incorrect statement. Now, as we had seen in case of substitution, if at some step you, instead of getting value for one of the variable, you get either an incorrect statement or a correct statement, then the situation is different. If we get an incorrect statement, which means that the lines are parallel and there is no solution for it. Had we got something like 0 equal to 0, some correct statement, then the lines would have been coincident and there would have been infinitely many solutions. So this is an example where you could get something like an incorrect statement and there will be no solution for it. And if you want to plot, you can plot and then you will see that these lines are parallel and there will be no solution for it. Also, one thing which we had looked is that the ratios a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. So it straight away gives you the parallel line.